Hello, this video is about electric circuits, subchapter 2 of electricity. Potential difference and electromotive force. These two terms have similar but distinct meanings. You have already met potential difference. Remember that is defined as the work done or energy transferred when a unit charge moves between 2 points. The term electromotive force, or we used to say EMF, is used where a source of energy, such as a cell, gives energy to a unit charge. However, it is a little more precise than this. If you fill a battery after it has delivered a current for some time it is warm, this means that, as well as the battery giving energy to the charge is doing some work in overcoming resistance in battery itself. When EMF is defined, this work is included. To make it clear, let's see this figure. It is often easiest to think that the two parts of a source of EMF quite separately. Now take a look at the circuit diagrams. Consider a battery of EMF E and internal resistance R driving a current through an external resistance R. The potential difference across the terminal of the battery is V. When you work with internal resistance, treat them exactly the same as resistance in any other circuit. Work through the following equation to ensure that you understand the relationship. Electromotive force equal current times resistance plus internal resistance. But current times resistance equal voltage, and therefore E is equal V plus I times internal resistance. It is clear that the source itself has a resistance. This is called the internal resistance of the source. Now look at this example. A battery is connected across a resistor of 6 ohm and an emitter of negligible resistance. The emitter registers a current of 1.5 ampere when the 6 ohm resistor is replaced by an 18 ohm resistor. The current falls to 0.6 ampere. Calculate the EMF and internal resistance of the battery. Following the problems, we can divide it into two conditions, condition 1 and condition 2. Now input 6 ohm resistor and currents to formula. It's become first equation. Consider the 18 ohm resistor to the formula and it becomes second equation. Substitute for E in the second equation. Therefore, internal resistance of the battery is 2 ohms. Substitute for internal resistance in the first equation. We will get EMF is equal 12 volt. Now, look at Kirchhoff's laws. The statement of Kirchhoff's first law is the sum of the currents entering any point in a circuit is equal to the sum of the currents leaving that point. It means that the total charge going into a point is equal to the current leaving that point. This figure shows the example how to calculate the current. Consider the currents going into the point as positive and those leaving the point as negative. Therefore, I equal 5.6 ampere. Kirchhoff's second law. In any closed loop in an electric circuit, the algebraic sum of the electromotive force is equal to the algebraic sum of the potential differences. Remember that the potential difference between 2 points is the work done per unit charge in moving from one point to the other. If the start point and the end point are the same, then the net charge change or work done must be 0. Figure shows a circuit. Calculate the EMF of cell E2 for the current through the emitter to be 0. To make it easier, you can manipulate or modify the picture. Now, consider the outer loop and move anticlockwise around the loop. 2.2 volt minus 6 times I minus 4 times I minus 1 times I equals 0. Therefore, electrical current is equal 0.2 ampere. And then, consider the inner loop which contains the 4 ohm resistor and the cell E2. Again, move anticlockwise around the loop. Therefore, E2 is equal minus 0.8 volt. The minus sign shows that in order to satisfy the condition, the cells should be connected the other way around. To find the total resistance of resistors connected in series, we can use Kirchhoff's second law. Let's see. Going around the circuit, V minus I times R1 minus I times R2 minus I times R3 equals 0. So, V equal I times bracket R1 plus R2 plus R3 close bracket. But voltage divided by current is equal total resistance. So, total resistance is equal R1 plus R2 plus R3. Now, we can use this formula to find the total resistance in series. To find the total resistance of resistors connected in parallel, we can use Kirchhoff's law. Using Kirchhoff's second law, we can see there is the same potential difference across each of the resistors. Therefore, I equal V divided by total resistance. I1 is V divided by R1. I2 is V divided by R2. I3 is V divided by R3. Using Kirchhoff's first law, I minus I1 minus I2 minus I3 is equal 0. I becomes I1 plus I2 plus I3. Therefore, V divided by total resistance is equal V divided by R1 plus V divided by R2 plus V divided by R3. And cancelling gives 1 over total resistance is 1 over R1 plus 1 over R2 plus 1 over R3. Potential dividers. A potential divider does exactly what the name suggests. If there is a potential V across AC, then the total potential drop is divided between AB and BC. So, V1 divided by V2 is equal I times R1 divided by I times R2. So, V1 plus V2 equal V input, where V1 is equal R1 divided by R2 times V2. So, R1 divided by R2 times V2 plus V2 equal V input. And then you can calculate like this. Then V2 times R1 plus R2 divided by R2 equal V input. So V2 is equal R2 divided by R1 plus R2 times V input. And look at this work, example 4. And now example 5. The figure shows 4 resistors and 2 EMF with internal resistance. Determine the electric current through all resistors. First, you can draw electric current direction. This is free for you to choose the direction. And using Kirchhoff's first formula, I1 plus I2 minus I2 equals 0. So I1 plus I2 equal I3. This is become first equation. And then determine the loop. You can choose like this, and loop 1 sigma E plus sigma I times R equals 0, and then minus 4 y minus 4 because the EMF first point is minus and then plus I1 times 1 plus I3 times 6 plus I1 times 0.5 plus I1 times 0.5, this part and that part equals 0. So 2 times I1 plus 6 times I3 equal 4. This has become second equation. So look at loop 2. Sigma E plus sigma I times R equals 0. So minus 2 because the point is exactly to the minus sign plus I2 times 2.5 plus I3 times 6 plus I2 times 0.5 equals 0. So 3I2 plus 6I3 becomes 2. Look at this first equation. I2 equal I3 minus I1. So 3 times I3 minus 3 times I1 plus 6 times I3 equal 2. Minus 3I1 plus 9 times I3 equal 2. This is third equation. Now eliminate second equation and third equation. 6I1 plus 18I3 equal 12 and minus 6I1 plus 18I3 equal 4. And then cancel I becomes 36. I3 equal 16 and then I3 equal 16 divided by 36 is equal 4 over 9 ampere. So I1 is equal to over 3 ampere and I2 just substitute to the equation is minus 2 over 9 ampere. Thank you for watching and see you in the next video.